So when it comes to circular measure, we actually looking at areas and perimeters of circles and shapes. And perimeter of a circle is basically the same as saying circumference of a circle. So you may use the words interchangeably so that you don't get yourself confused. In case I say perimeter of a circle, and I
Okay.
actually mean the same thing as saying the circumference of a circle. So we should know the basics of circles before we can actually do something fruitful. When I say the basics of circle, I need you to know what the area of a circle is. Also, I need you to know what the circumference of a circle is. In most cases, we're going to deal with radians, radian measure, and let's start. So when you've got a circle this way, just like you can see, the black part of the circle, whatever you see in black, is basically forming the circumference of the circle. You get?
Okay.
So that's the circumference of the circle. Now,
Mm.
when a dot is within the circle, in most cases, this dot is going to be the center. Like I said earlier, we're looking out for radians. And when we talk about radians, it's also angular measure. And do you know what radian actually is?
Isn't the radian the radius?
No, the radius is something else. It's different from the radian.
Mm-hmm.
Okay, so the radian is basically an arc equal to the length of the radius. This is what the radius is. The radius is any line drawn from the circumference of the from the center to meet any part of the circle, any part of the circumference of the circle. So these red lines are radii. So this is a radius, this is a radius. So once it's coming from the center, it's going to be and touching the circumference is radius. So all these lines are said to be equal because they are all the same. Now, when I talk about radian, that is the angular measure radian. This is basically talking about the angle that you to take so that the circumference of a circle becomes the radius of the circle, becomes equal to the radius of the circle. That's what I mean.
So the angle in a sector.
Basically, the angle in the sector. So assuming this line is, let's say, 8 centimeters. Let's just say 8 centimeters, and the radius is also 8 centimeters. Then we say that this has traveled 1 radian. Is that okay?
Yeah.
So basically, is the angle covered such that the length of arc is equal to the radius of the circle. So if this is 18, then this is not 1 radian. It's going to be more than 1 radian. So once the radius is the same as the length of arc, we actually calling that angular measurement a radian, so 1 radian. Now, mathematically, we say that 180 degrees, that is from degrees, is equal to pi radians. So 180 degrees is equal to pi radians. The full circle, which is 360 degrees, is equal to 2 pi radians. So that is something you should also know. It's going to help you out in Math D, since in Math D you do most of the calculations in degrees, not radians. So you really understanding this one is going to make your Math D um, easier in a way. That is, if you don't get so comfortable with the radians. But if you do get so comfortable with the radians and you are dealing with MADI, all you need to do is to remember these conversions. So you can do your entire calculation in radians, then later you convert it to degrees, and that will be fine. Okay, so that is one thing that you should know, and we can continue from there. Can I continue, please?
Yeah.
Okay, so converting degrees to radians, I'm not really going to talk much about that, but let's go into details. Again, the part of circle, we talk a little bit more on the part of circles. Then we see if we can derive some of the formulas and we solve some questions. So this should be the center. This should be around the center. So earlier I was like a line drawn from one part of the center to any part of the circumference is called the radius. And the radius, or let's say two radii, are always of the same length. So if this line is 8 centimeters, why am I using 8 like that? Then it means that this is also 8 centimeters. So that's one thing you should be aware of. Are we good?
Yeah.
Okay. Now, when you look at this side of the diagram, this side to the side, the blue line you're seeing over there, that is called an arc.
Okay.
That is called an arc. So it's a part of the circumference. So the circumference of a circle is actually the total black line you see. That is the black outer part you see of the circle. That is the circumference. The arc is basically a portion of the circumference. Are we good?
Yeah.
Okay. So let me retake this again. Then we talk about another part of the circle. Let me delete this one. No, come on. Okay, this thing doesn't want to do it. Okay, so a line joining one part of the circumference to the other part of the circumference is actually called a chord. So a line, any line from one part of the circumference joining another part of the circumference, this is called a chord. Is that okay?
Yeah.
So this will also be a chord. The black line you see, this is a chord. This is a chord. Once it's from one part of the circumference to another part of the circumference, it's referred to as a chord. Later on, we will come to derive a formula for length of a chord. So if I say a chord, you should know what I'm talking about. Now, the chord actually divides the circle into two parts called segments. So again, if I've got a circle, this is a circle and I circle, then I've got this chord. The chord divides the circle into two segments. So this is one part of the segment, and this side is also another part of the segment. Is that okay?
Yeah.
Again, we'll come back to this one and we'll talk about how to find area of a segment. But first, you should know what a segment is so that when I talk about it, you don't get yourself confused. So a chord divides a circle into two segments. We've got the major segments. The major one is the bigger one. And we've got a minor segment. But it doesn't really matter. The formula is going to help you out with that. Another thing we're going to talk about should be a sector. I think that should be my favorite because it looks like a pizza slice. Someone said that in a way I was trying to challenge the person, but just for the fun of it. Okay, so it's more or less like a pizza slice, and a sector is formed out of two radii. So an arc and two radii forms a sector. So there's always going to be an angle over here, since the radii are connecting to the circumference. So normally, this is what you're going to see, but in some cases, you're going to see. Okay, let me see. In some cases, you may see just the sector that way. So this thing, everything is out, and you're going to see only this one. We get
Yeah.
okay. So this alone is also a sector. So it's just like a pizza slice. So we're going to go into details now to look out for the formulas that we can derive out of this. I would advise not to really focus on formulas, but try to focus on understanding the concept, because if you do actually understand what is going on, it becomes very, very easy for you to solve most of the questions. Okay, so okay, let me. It doesn't matter. Now, at senior school, you did something on area of circles and circumference of a circle. What is the area of a circle?
Pi r squared.
That is pi r squared. So that is the full circle, right? Like the area, the space covered by the full circle, the entire circle. So if I
Mm-hmm.
want just a portion of the circle, then we should do
3
something
over
about it. A full circle gives you an angle of what?
360. So it's
Three-
360
360, 360,
over pi
degrees.
over the radians.
Okay. So let's say that we now deal with just a center. Let's say the radius of this circle is let's assume that it is 14 units, or let's say 7. Let's say the radius of this is 7. Taking pi is between 2 over 7. We are not always going to take pi is between 2 over 7, but let's assume that pi is 22 over 7. It's actually not 22 over 7. This is a rational number. Pi is an irrational number. So, but this is just an assumption. If pi is equal to 22 over 7, what is going to be the area of the circle?
22 over 7 times 7 squared.
Okay, so there's going to be 22 over 7 times 7 squared, which is going to be equal to what?
Coming. 154.
Okay, so that's going to be 154. So the entire area is 154. Now, if we are looking out for just a portion of the area, in this case, I'm looking out for the area covered by the radii and the path, such that the angle between the two radii is 30 degrees. So you can see that this is not the full circle. Is that okay? So definitely we are looking out for an area that will be lesser than 154. The reason is that some parts of the circle has been taken off. An area is the space covered by the entire figure. So if some part has been taken off and you're only interested in a portion of it, you should note that you are not going
360.
to get the same answer. So let me say that this part has been taken off.
Won't it be 360
So
over the angle?
it's just going to be the angle that is a fraction of it. So a fraction of this, so 30 over the total angle is 360, right?
Mm-hmm.
Times pi r squared. So in this case, 30 over 360 is 1 over 6.
Mm-hmm.
Okay, then times no, it's not 30, it's not 1 over 6. This is wrong. I think 1 over 12. 312 is 36. Times 22 over 7 times 7 squared. Okay?
Yeah.
Then you solve this one, you work this one out. So working this one out, we should expect to get the answer lesser than what we got before. So that's 1 over 12. Come on. So 1 over 12 multiplying this, that is 77 over 6. So we've got 77 over 6. That is going to be our area of the sector. But basically, this is monthly since we are using that of degrees. So in a typical circle, let's say a typical circle, we've got a typical circle this way. Then this is my sector, and this angle over there is theta instead of a value like 30 degrees. You see, previously we were like 80 over 360, right? in solving this question is the angle divided by the total angle times pi r squared. But what is the total angle of a circle in terms of radians, not degrees?
I don't know.
Oh, I wrote it earlier. What is the total angle in terms of degrees of a circle?
Pardon?
What's the total angle in terms of a circle?
In degrees is
Yes,
36.
in degrees is 360. And earlier I was like, 180 degrees is equal to what? Forgotten, pi. So it means 360 degrees will be equal to what? Yeah, we wrote this earlier. So, okay. So because we are dealing with radians, we say
Giovanni is joining.
Giovanni is joining.
He said you join in like 10 minutes.
Okay, okay. So since we are dealing with degrees.
Oh,
Sorry.
thank you.
Yeah.
Thank you. No, thank you.
Eh, okay,
He said?
it's fine. They brought you food.
Yep.
Okay. Let's continue. Since we are dealing with degrees. Sorry, since we are dealing with radians, we're saying that to find the area of this, there's going to be theta over. Assuming we're dealing with degrees, just like we did previously, we did 30 over 360, isn't it?
Mm-hmm.
So this time we are dealing with radians. It's going to be the theta over 2 pi. Are we good? Since 360 is equal to 2 pi in terms of radians.
Now to change of subject.
Coming in,
Change of subject.
not change of subjects per se. You see, this working is actually in terms of degrees because
Mm-hmm.
the angle given was degrees and the denominator is also in degrees. But in art math, most of your calculations you're going to do will be in radians. So if this angle is in radians, that means the denominator should also be in radians. So in terms of a full circle, the angle in radians is 2 pi. Since 360 degrees is equal to 2 pi. We know that in a full circle, the angle is 360 degrees, right? So I'm just
Mm-hmm.
transferring that knowledge to in terms of radians. So if 360 is equal to 2 pi, then it's not wrong to do divided by 2 pi. So if I'm to find the area of the sector, it's going to be the fraction that is theta over whatever the total angle times pi r squared. In this case, you can do some simplification. This cancels out. Then this gives you 1 over 2 theta. Let's say r squared theta. It's 1 over 2 r squared theta. And this becomes the first formula derived. So area of a sector is equal to 1 over 2 r squared theta. Please, you are not supposed to forget this.
Okay.
Okay, so that is 1 over 2 r squared theta. Now we continue. Can we continue?
Yeah.
Okay, so that's the first formula, area of a sector. Now we move on to something else that is going to be the length of an arc. So again, we're going to take the concept from somewhere in grade 9, grade 8, where you can find the circumference of a circle. So what is the circumference of a circle?
2 pi r.
Okay, this is equal to 2 pi r. So let's say a radius with a circle with radius 7 centimeters, taking pi to be 22 over 7. What is the circumference of a circle? Or someone can say perimeter of a circle. So taking pi to be 22 over 7. What is the circumference of the circle?
Come on. Um, 44.
44. Okay, so in this case, it's going to be 2 times 22 over 7 times 7, which is going to be equal to 44. Now, I did say something earlier. I was like, if you are interested in just a portion of the circumference, what is the name given to it? So from this side to this side, what will be the name given to it?
Hey, sorry, arc.
That is going to be arc, right?
Yeah.
Okay. So how do you find the length of this arc? So this is a portion of the circumference. So we should expect that our answer should be a little bit lesser than 44.
60 times
Come again.
circumference.
Come again.
Theta 360 times circumference.
So 80 over 360, that is the theta, and the circumference of the circle, that is 2 pi r.
Okay.
So in this case, this gives you 1 over 12, change 2 times 12 is 36, times 2 times 22 over 7 times 7. So this cancels out, and this is basically 44 over 12, and 44 over 12, I think 4 can divide both of them, so 44 over 12, this should simplify to 11 over 3. So 11 over 3, and that becomes the circumference of that circle. So since this is not the entire circumference, we say that this arc, so the length of arc is equal to 11 over 3. Can I continue?
Yeah.
Okay.
Won't you do it to radians? Or?
Yeah, so this is a question in degrees. So let's transfer the knowledge to that of radians. So in this case, let's use the radius to be r, and this is going to be theta. So just like you said, it's going to be theta over 360. But since we are dealing with radians, it's not going to be 360. Instead, it's going to be what? It's not going to be 360. What is it going to be since we are dealing with radians?
Radius. Oh no.
You see, previously it was 30 over 360 times 2 pi r, right? Now we are dealing with radians. What is 360 in terms of radians? What is 360 degrees in terms of radians?
Pi.
No, try again.
Whatever the radius is.
No, we've forgotten again, Sarah. Okay, so we just wrote this one. In terms of radians,
Sorry, 2 pi.
2 pi. Okay, so theta over 2 pi times the circumference of the circle, which is 2 pi r. So you can see that this 2 pi cancels out this 2 pi, leaving you with theta r. So we say that length of an arc. So length of arc is equal to theta r. Length of arc is equal to theta r. So write out this formula as well. So far 2 formulas. Okay. So that is length of arc is equal to theta r, and area of a sector is 1 over 2 r squared theta. Can we continue?
Yeah.
Okay. Because this topic deals with a lot of shapes, we would have to also learn a little bit on triangles. What do you remember about triangles? Especially right angle triangles.
90 degrees.
So there is a 90 degree over there. Then
So then you have to pay for the hypotenuse.
so there is hypotenuse over there as well. There is opposite and there is adjacent. Okay, so I'm not really interested in those kind of stuff. Actually, I'll come back to that. But how do you find the area of a triangle?
1 over 2.
1 over 2
Base times height.
base times height. So which one is the base? Which one is the height? Which one is the other one? So which one?
Yeah. It doesn't work for this.
It does actually. When it comes to this one, the right angle triangle, this formula is perfect. Half base times height. But which one is the base? Which one is the height? Let's say we've got A, B, C. Which side is the base? Which side is the height?
C is the base, A is the height.
A is the height. Okay, it doesn't really matter. A can be said to be the base and C can be said to be the height. The thing you need to notice is that the base and height always meet at 90 degrees. Is that okay?
Yeah.
So the base and the height always meet at 90 degrees. So if they are not meeting at 90 degrees, they can't be either the base or the height. We good?
Yeah.
Okay, so if you come across a triangle of this nature, so we've got A, B, C. So you can see that in this case, the height is going to be the vertical thing you see over there, and the C is going to be the base. We get
Yeah.
they always meet at 90 degrees, and at times it could be that the base and the height, is actually outside the base. This is what I mean. Let me draw it all. So let's say this is a triangle. Okay, this is a triangle. In this triangle, from my D, I think we should learn that from my D. The height of this can be outside the triangle. Is that okay?
Mm-hmm.
Okay, so in this case, we've got A, B, C. C can be my base, and the red line is my height, and the formula is still going to work. But this formula is more or less like restricted to a lot of things. First, you need to find the altitude, that is the height of the triangle. But what if you're dealing with triangle is that you can't, it makes it a little bit difficult. As a result, there is another way of finding the area of a triangle. But before we go, let's at least use this formula to see if we can solve some questions. Let's say the base of this is going to be, let's say, 8, and this is 6. Okay. So what is going to be the area of the triangle?
It's going to be 8 times. Sorry, half 8 times 6.
Okay, and what would that be?
Mami. Wait, 4 times 6, 24.
Okay, so that is 24. Okay, so that is a very, very basic way of finding the area, which it works, but it has got its own flaws. It has got its own restrictions. So personally, I don't like this because this is not a general way of finding the area. Instead, the general way of finding the area of a triangle is 1 over 2 AB sine theta. I will explain. So this AB is the size of a triangle, and the theta is an angle between the side A and B. So let's say we've got a triangle this way. This is not a right angle triangle. Let's say we've got the side to be A and this side to be B, and there is an angle between A and B. This angle is theta. This is saying that the area of the triangle is basically 1 over 2 AB sine theta. Hold on here. Okay, so this is the best way to find area of a triangle when the sides are given. I think there are a lot of ways. I can think of 4, 5 different ways of finding area of a triangle.
Mm-hmm.
Yes, but this is so far my favorite. Let's try to use that one to answer the question that we solved earlier. In this case, the size of the triangle, we know one side to be 8 and we know one side to be 6. Do we know an angle between the two sides?
90.
90. So we say that the area of this is
It's a 90.
1 over
90.
2
Yeah.
times 8 times 6 sine 90. Is that okay?
Mm-hmm.
So let's use that one and see if we can get the answer. I think this still gives you 24 if you type this on the calculator.
This is one.
Yeah. Done again. So you can see that this also worked out.
Let me join. There's no point. Isn't the class ending in like 6 minutes?
When did this start? It's 1 hour 30 minutes.
Ah, okay.
I'm actually recording the screen, so okay. So
Ah, okay.
this will give
Let
you
me join.
24. This will give you 24 as well. So this is a better way of finding the area of a triangle instead of going through the process, that lengthy process. So let's take a random triangle this way. Let's say this is 45 degrees, and this is 10, and this is 18. What is going to be the area of the triangle?
It will be half 10 times 18 sine 45.
Good. So let's type this on the calculator. Let's see what that gets us.
And 45 will be 0.5, won't it?
Come again?
And 45 won't it be 0.5?
No, so 45 is said 2 over 2.
Hey, okay.
Eh, okay.
Why?
No, not nothing. I thought you should know that. Right, it's fine.
Um,
It has
uh,
skipped you.
Colin?
Probably it has skipped you.
Okay.
Okay, so the answer is 45 said 2.
I thought you wanted like an actual number.
But 45 said 2 is also a natural number.
Ah, okay. So give me 76.
So the
So you give me 7.0.
7.0,
Mm-hmm.
are you sure?
Mm-hmm.
Get the sign 45. Just type, we are using a calculator, so just type on the calculator.
Okay.
So input everything on the calculator. Just type everything on the calculator and you'll be fine.
Okay. Come in. There was 630 something.
When you type everything on the calculator,
Yeah.
no, it's 63. What are you typing in the calculator? What did you type on the calculator? Can you see my screen? Okay, you can't see the calculator on my screen.
No.
Oh, sorry, my bad. I'm just sharing the other one. Oh, sorry. Okay, but let's type on the calculator. 1 over 2 times 10 times sine 45.
Ah, okay. That's
So
first it.
yeah, so 45 said 2. That is the answer, right? Okay. So do you get how to find the area?
Yeah, I understand.
Okay. So you can also add that one to the formulas.
I have.
Okay. So far let's get a summary of the formula so that we don't forget. We keep track. So the first one was area of a sector. Area of a sector in this case is going to be 1 over 2 r squared theta. Then we've got length of arc. Hold on. Yeah, length of arc. So length of arc is equal to what?
Length of arc in radians or
Yeah, in radians. We've derived this already.
yeah, I know it pi r.
Hey, I'll come there and give you like 2,783 lashes.
Ah, why?
We derive it as pi r. And yet theta, r theta, or theta r.
Sorry. I was saying yes. I was saying theta, but then pi came out. I meant theta r.
Okay.
Sorry.
R theta or theta r, anyone. I like r theta better. So r theta. Then we know area of a triangle.
Mm-hmm.
Area of
1/2 AB sine
okay. Area of a
theta.
triangle. This is going to be 1/2 AB sine
Sine.
theta, where the theta is between the length A and B. Can we continue?
Mm-hmm. Yeah.
Okay, so let's move on to another formula. That is going to be area of a segment. Area of a segment. With your permission, I would like to put this on maybe YouTube on my channel.
All right.
Okay. Again, if you forget, you can go back and uh, view the well, like
You, uh,
the
you,
video. Yeah. So, what is a segment again? Do you remember a segment?
pardon?
Do you remember what I say? I said the segment was.
Mm-hmm.
Yeah. What did I say about segments?
The line cut by a cord. Like when a cord cuts the distance, the two things made.
Good. So once there is a chord, the chord kind of separates into two segments. So we've got the major segment and the minor segment. So let's say that this is a segment, then this a radius, and this also under radius. So the segment will be this part of the circle. Is that okay?
Yeah.
Okay. But the entire thing that is from this side to this side to this side, what is it called?
The sector.
Good, a sector. So we're looking for just the segment. So the segment is a part of the
20,
sector.
20
Okay.
calculate the triangle.
Yeah.
That is calculate the circle, then calculate the triangle and take away.
Okay. So we're going to calculate that of the sector, then calculate that of the triangle, then you take away. That is very, very good. So the radius is r in this case. So how do you find the area of the sector? So let's say the area of the sector will be written in red. Area of the sector. We
Every half
have
radian squared
r
theta.
squared theta. Is that okay?
Mm-hmm.
And what is going to be the area of the triangle?
But then
What's going to be area of the triangle?
1/2 AB sine theta.
So in this case, what is A? What is B?
1/2 R. There's no number for it.
Yeah, so we are using the letters 1/2 R. Sorry, 1/2 R. So you are talking and you are eating. You know that
I'm
is
not.
that is.
I'm
Are,
eating.
are you done eating?
Yeah.
Okay. So 1/2 R. A is my R, and B also turns out to be my R. Is that okay?
Yeah.
Sine theta. So this simplifies to 1/2 R squared sine theta. Are we good?
Yeah.
So we're saying that the area of the segment now becomes the area of the sector minus the area of the triangle. Is that okay?
Yeah.
So that is area of sector minus area of triangle. So the area of sector was 1/2 R squared theta. Then the area of the triangle was 1/2 R squared sine theta. So we can do something very nice over here. Factor out 1/2 R squared. If you do that, you'll be left with theta minus sine theta. And that becomes the formula for the segment. So area of a segment is equal to half r squared sine theta. Half r
Okay.
squared sine theta.
Where's my pen?
Half r squared sine theta.
Area of segment.
I think Giovanni is in. The area of the segment is given as 1/2 r squared sine theta. So from there, we can talk about the last one, the length of a chord. Length of a chord. Can we continue, please? Sarah, can we continue?
Yeah.
Okay, so length of a chord. So taking a circle, because definitely this is going to come. Like you can't write and add math paper without this. It's going to come. And it's normally comes in paper one. So the blue line over there is a chord. And connecting the chord is two red lines forming a triangle. With this one, we can see that the triangle over there is an isosceles triangle. I continue.
Yeah.
Okay, so this is a radius and this is a radius. Property of an isosceles triangle. Two sides are equal and the height of the triangle divides the base into two equal parts. So whatever angle over here, that is going to be, if the full angle is theta, or first, if the full angle is 30 degrees, it means that one side will be 15 and the other side will be 15. Is that okay? That's okay. The line divides the angle into two equal parts. Is that okay?
Yeah.
Okay. Yeah. Joe, is that okay? Is it there? Okay. So there's theta over 2 and there's theta over 2. And this side will also be equal. So first, let me bring out the triangle, draw it a little bit bigger. So just a portion of the triangle. This angle is theta over 2. This is the radius, and this is what we are finding. Let me call this x. So I can say that sine theta over 2 using SOHCAHTOA is equal to x over r. Sine theta over 2 is equal to x over r. Since sine is opposite over hypotenuse, so the opposite was x and the hypotenuse is r. So in this case, I can say that this is going to be x is equal to r sine theta over 2. R sine theta over 2. We good?
Yeah.
Okay. So this becomes just one part of it. The chord was twice as long as this one. So if one part is r sine theta over 2, it means that the other side will also be r sine theta over 2. So the full length is going to be the full length. So length of chord is going to be the x over here plus x over here. So x plus x. In this case, this gives you r sine theta over 2 plus r sine theta over 2, giving you 2r sine theta over 2. So this becomes the formula for length of chord. And I think that should be the last part of what we're going to do. The formulas then. Next time we'll use the formulas to answer as many questions as possible. So let's summarize the formulas again. Sarah, please write this one down. Joe, are you there?
I've written it down.
Okay. So let's summarize all the formulas. So we've got the first one again, length, sorry, area of, come on, I did something. Control C. Okay. Okay, so we've got the first one to be area of sector. Area of a sector is given as what?
In radians or
In radians, yeah.
1/2 r squared theta.
Okay, so the next one, we've got length of a chord, sorry, length of arc.
Theta r.
Okay, or r theta r. So that is fine. Then we've got area of a triangle.
1/2 ab sine theta.
So 1/2 AB sine theta. In a circle, so triangle in a circle,
Hmm?
this would be 1/2 r squared sine theta. It doesn't matter, it's the same thing. Remember when we were doing this one, we did the A to be r and the B is r. And so that is r squared sine theta.
Okay.
Okay, so
Go down. Write it down.
okay. Then we've got area of a segment.
Then
Area of a
one over
segment
two r squared
r squared.
and theta minus sine. Oh.
Yeah, theta minus sine theta. Then finally, length of arc. Sorry, length of a chord.
R squared a. Oh. No, it's rather 2r
2r
sine
sine
theta.
theta over 2. Don't forget that.
Okay.
2r sine theta over 2. So try as much as possible to get this one memorized. You derived all of them. In our next lesson, we're actually going to use them to solve a question.
Okay.
Okay. Or we just solve one question. We can't go into details over there. We just solve a question, then we we will pause for today, then we'll continue later. Okay.
Okay.
Let's try to solve this question. Oh, I didn't copy the question. To be terrible. Okay. Okay, so yeah. I don't know if you can see the shaded part. Yeah. This is the shaded part. I don't know if you can see. Can you see? Can you see the shaded part?
Yeah.
Yes, please.
Okay. They're talking about this side. Okay, so the question goes this way. A circle has radius 5 centimeters and center O. P is a tangent to the circle at PQ is a tangent to the circle at the point P. QRO is a straight line. Find angle POQ in radians. POQ. So that's the angle we are looking for in radians. Now, one thing you should know is that anytime there is a tangent and this one, tangent and normal always meet at 90 degrees. A line through the center is called the normal, and the tangent and the normal meet at 90 degrees. So we have to find the angle theta. This is a right angle triangle. This is a right angle triangle. I'm trying to bring out the question. This is a right angle triangle. This side was given as 12. This side was given as 5. And this is 90 degrees. And we are finding theta. Which of the trig ratios are we going to use? Tan, because this is opposite and this is adjacent. Opposite and adjacent has been given. So we can say that tan theta is equal to opposite, which is 12, and
Over 5.
over 5. Please make sure your calculator is set to radians. Please make sure your calculator is set to radians. So you know how to set your calculator to radians, right?
Yeah.
So Yo, what about you?
Yes, please.
So shift and setup and angle units. Then you choose radians. Okay. So tan inverse of 12/5 gives you 1.176. So we say that theta is equal to 1.176. Is that okay? Is that
Yeah.
okay? So we found the first part of the question. The second part of the question says you should find QR. Sorry, yeah, QR. QR is going to be from side all the way to the side. But because it's a right angle triangle, we can actually find from this side all the way to the side by using the Pythagorean theorem. So in this case, the Pythagorean theorem goes this way: h squared is equal to o squared plus h squared. H squared, we don't know what h is. O is 12 and a is 5. So in this case, you do this, and if everything is correct, you should get 13. Take your time and do this. You should get 13. So let's confirm 12 squared plus 5 squared. That is from Pythagorean triple. So there should be 13. We get
Yeah.
so the entire thing is 13, but from this side to this side is radius. So this will make the side to be 5 centimeters as well. Therefore, if the entire thing is 13 and this side is 5, what is going to be QR? Anyone? What is
Pardon?
if the from Q to O is 13, we calculated that as 13. And we know
Mm-hmm.
from R to O is a radius, which is also 5 feet. Then what will be Q to R?
13
8.
plus 5, 8.
Okay, so 13 minus 5, which is 8. That is going to answer this question. Now, the last one, we have to find the perimeter of the shaded region. So, perimeter of the shaded region, we already know the 8, which is fine. Perimeter is the shape, sorry, the length around a shape. So, we already know the side. Let me indicate the ones we know. We know the side to be 12. We know the side to be 8. So, we are left with one side, which is the arc over here. Over here. Which means that we need to find the length of the arc, then add it to the other shape there. That gets us the perimeter. Can we continue?
Yeah.
Okay. So the length of the arc over there, in this case, what is the formula for length of arc?
Theta R.
Okay. This is equal to theta r. We got the theta to be equal to 1.176 and r in this case was 5. So 1.176 times 5, what will you get for that? 1.176 5, that will give you 5.88. So 5.88. We get
Mm-hmm.
okay. So it means that this side is 5.88. If that is the case, then we can say that the perimeter. So perimeter that you are looking for is going to be the length we know, that is the 12 plus 8 plus 5.88. So 12 plus 8 plus 5.88, and that should give you 25.88. 25.88. And that answers the question. That's okay.
Yeah.
So tomorrow we'll solve more questions on this. We'll solve an entire full page. Sorry. We'll solve topical questions on this. That's what I meant to say. Okay, so that'll be
So, when do you do evening class?
come again.
When do you do evening class?
Evening class. I'll see my schedules. If I get time, I'll actually evening class. At what time will you be free? At what time will you be
That
free? Because currently my last class ends at 9.
Hey,
I'll see 8. Okay, okay. I'll get you a time over there. It's likely some people won't come, so if they don't come, I'll let you know then. Because you guys, yeah, you've got less than you've got a few days to your paper, so no,
A few days.
a few months. Sorry, our months include days, so I'm not wrong technically. Okay, but I can even
Okay,
see
what about Oniba and Kelvin?
Iniba and Kelvin. I didn't get in contact with Iniba. Kelvin is at the hospital. I was told he's not feeling well. Yes, so try to get in contact with Oniba. When I when I got him, he told someone to tell me that he's going on. So I didn't get to talk to him. Do you have his number?
No, please.
His snap?
No, please.
Okay. You just try. Let's try to get in contact with him. He doesn't know, but I've sent
For,
him an email. Come again?
for Hannibal.
Yeah.
I have his snap.
Okay. So try to message him as well. Okay. Okay. That'll be all for today. We'll meet some other time. Please solve questions. Okay. Just try to solve some questions so that when you get stuck, we can discuss them later in the day, maybe in the evening or
For sure, for sure.
tomorrow.
For sure.
Okay. Yeah, Charlie. If they come and you carry my this thing,